So our next lesson is a review. It's not calculus, it's a pre-calculus review on logarithmic functions. And then when we do that, it's can you take the derivative of a logarithm? So, since f at x equals e to the x is 1 to 1, it's continuous and increasing, it must have an inverse. However, if you wish to switch x and y in the equation, you get x equals e to the y. How would you get y by itself then? You need a logarithm, because a logarithm undoes exponential. So you can't isolate the new y by using algebraic methods, so we must define the inverse as a function, and we define it, in this case, as a natural logarithm for e. And instead of writing it, we write it as a logarithm. What does ln stand for? What base is that logarithm? E. And it's a special logarithm with a special symbol, ln. So that x equals e to the y and y equals ln x are equivalent. In general, if you have an exponential function, then the inverse is a logarithm, right?
Yeah. Right.
Yeah.
Uh-huh.
So note that that logarithm with a base e is written with the symbol ln, and if it has a base of 10, we call it a common logarithm, and the base is empty, right? So if you see an empty base, that means the base is 10. Does this feel like 1,000 years ago?
Yeah.
But you know this is review in your heart. All right, let's talk about some basics about the functions. Again, this is pre-calculus. What's true about the graphs of a logarithm? So the domain for a logarithm goes from 0 to infinity, but does not include 0. A logarithm has a vertical asymptote at 0, and we can transform it. The range, however, goes up forever and down forever. So the range is all real numbers. There's a vertical asymptote at x equals 0, which is the same as the y-axis. What does this mean? The limit of the function as x approaches 0. So as the graph approaches 0, what direction is it pointing? To negative infinity, right? And then also, notice that talks about the behavior at 0. What's the behavior as x goes to infinity? What's the function doing? Also, right? So the right-hand behavior is going up, but slowly. The graph of the function is continuous. It's increasing. It's concave down. Do you see the one on the right is the logarithm? An exponential is concave. You can talk to me. An exponential is a concave up. A logarithm is concave. Now, one of the properties of inverses is it reflects over, right? And when you reflect a happy face, it becomes a frowny face. Notice that we have a point at 1, 0. We also, that a represents the base. That if you know the base of the logarithm, it's the base and 1 to be able to graph it. So, it says use a calculator to graph y equals ln x and y equals log x in the same coordinate planes. And do you see any similarities between the two graphs? We don't need a stinking calculator, right? So, the starting point for any logarithm is 1, 0. Do you know why that's the starting base for all logarithms? Because when you plug in 0 for the exponent, the answer is always 1. So think about it this way. If you had a logarithm and the x value is 1, what must the exponent be? So the answer is 1. So a to what exponent is equal to 1? And it doesn't matter what the base is. The base to any exponent 0 is always equal to 1. So whether it's log or ln, they share the same point. And what point would you start with when you graph any logarithm? 1, 0. Now, we could transform it. Is there any adding, subtracting, multiplying, or dividing to transform these functions? No. So they both start where? At 1, 0. Now, the second point is going to be the base in 1. Well, do they have the same base? No. So what's the 1 base for ln x? You don't see it, but what's the base for ln x? So we're going to have e and 1. Now, e is approximately what again? 2.7. So can you approximate 2.7? That's 3. So 2.7 and 1. And then what is the curve of a logarithm going to look like? What direction does it go? And they both share the same asymptote. Where did it say the asymptote was over? 0 or the y-axis. So what's the behavior at 0? Where's this going? To negative infinity. And then it curves up, but it increases slowly, but still increasing. So what did we just graph there? Ln x, right? So what do I expect when you graph it? 2 points and an asymptote. Can you see the 2 points in the asymptote? Log x, what's the base there? 10. So what's the point on that logarithm? Can you find where 10 and 1 are? The same idea, but this one, the bigger the base, the slower it increases because it's a logarithm. Exponentially be the other way, right? The bigger the base, the faster it increases. For a logarithm, the bigger the base, the slower, right? It increases. But does it have the same kind of behavior of a curve? It's just which one increases faster. So what do they share in common? The asymptote and what point? 1, 0. And the second point is determined by the base. And that determines whether it increases faster or slower. All right, now we're talking without using a calculator. Sketch a graph of the absolute value of ln x minus 2. All right, let's start. For any logarithm, what's the starting point? Good. Now, look inside the logarithm. Do you see something that's affecting the x-coordinate inside? Think of it as a transformation. And for x, it's the inverse of what you see. So we're not subtracting 2, we are adding 2. The only way the y is going to be affected is the absolute value part. What is the absolute value of 0? 0. So where's a point on our graph? Good. What's the second point? It would be the base. What's the base that you don't see? E and 1. So if you're going to graph a logarithm, it's 1, 0, and whatever the base is, and 1, and then you transform them. Again, how is this going to change? Instead of e, which is about what again? 2.7. What do we do to it? Add 2, so it's about what? 4.7 when you add 2. And the 1, what is that? And the absolute value of that is still 1. So at 4.7, you go to 1, and you can see the picture going to the right. Correct? Where's the asymptote? Normally it's at x equals what? 0. To transform it, instead of subtracting 2, we're going to add 2. So over 2 is going to be the vertical asymptote. Normally, what would this curve look like for a logarithm? As we're going to the left, what direction would it go? But what does the absolute value do to all of these negative values? So all these y values would be negative. They all become what? And there's the graph. Yes, that means right there, there's no derivative, is there? But all the other points would have derivatives. But do you recognize what the absolute value does to the y coordinates, right? It makes all the y coordinates positive. So if they're positive, it stays positive. But all the negatives become positive, and you connect them together. All right, turn the page. This is going to be easier to remember, I promise you. Do you know how to change something that's exponential into a logarithm? If you look at example number 3, 3 to the 4th equals 81. Do you know that's in exponential form? How would you write that as a logarithm? Do you remember that? There are 3 parts to this. Yeah, the answer, the exponent, and the base. You came alive, right? Because you remembered it. I want you to recognize first the exponent. What number is that? The logarithm is going to have the same base as the exponent, which would be? And then the answer that goes inside the logarithm? Done. So can you write it as a logarithm? How about B? Can you write that as a logarithm? What's the exponent? What's the base for the logarithm? E, right? And that has a special symbol, which is ln, and what goes inside the logarithm? See? I knew you remembered that. How about for C? What's the exponent? -1. Oh, yeah, we're going the other way, right? La la la. What's the base? Let's start there. 10. And what's the exponent on 10? And then what's the answer? Here are some basic properties. Because e to the 0 equals 1, what does ln 1 equal? They're connected. When you evaluate a logarithm, you're finding the exponent that makes it true. So, what exponent would give you the answer 1? The only exponent that would give you the answer 1 is 0. Since e to the 1 equals e, then what does ln e equal? Yes. These help you simplify things, right, in calculus. Because zeros and ones, right, are good simplifiers when you see them. Gardini, can you see that e to the 1 equals e and that follows ln e equals 1? This is what it means. Look, when you see ln, what base don't you see? E. E to what exponent is equal to e? 1, right? Like e to what exponent is equal to e? What would that exponent be to make it true? 1. That's all it's saying. So if you see ln e, you can take it out and put in what number? And if you see ln 1 or log 1 or any logarithm with a 1 inside, you can take it out and put in what number? 0. That's what it's saying. Because natural exponential function and the natural logarithmic functions are what? So what's a logarithm again? Oh, say it like your heart means it, right? A logarithm, right? Because it's like the word trigonometry or something. It just seems complicated to say in the word, right? But it's not. A logarithm is the inverse of an exponential. That's it. Because they undo each other, right? If you have ln e to the n, the ln and the e undo each other, and what are you left with? Just n. Or, if you have e to the ln n, e and ln undo each other, right? The exponent and the logarithm, like adding and subtracting, or multiplying and dividing. So they undo each other, what you'd be left with? Just n, right? They're inverses, right? Adding, subtracting. Multiplying, dividing, right? They undo each other, and then that's what's left. This is the easiest one we're going to do. Ln e to the root 2. If they undo each other, what are you left with? Root 2. Can't be that easy, right? E to the ln 3x. If they undo each other, what are you left with? 3x. 10 log 2. What's the base you don't see when it's a common log and an empty base? It's 10, right? They undo each other and you're left with 2. How about this one? Here's another property that can be helpful here. Do you know that when you have an exponent inside a logarithm, it can be written as a product in front? Do you know that x squared can be multiplied in front outside the logarithm rather than inside? What's log 2 base 2? Because what exponent makes it true? 1. And x squared times 1 is just... Do you need a reminder of some properties of logarithms? Here it is. When you're multiplying and you want to expand a logarithm, what do? Add. When you're dividing, what do you do to expand it? When there's an exponent inside the logarithm, if you want it outside the logarithm, what do? Multiply, right? A product in front. And remember that the bases have to be positive, right? In terms of what we're working with, A and B there, in the numbers. Okay. Can you expand example number 6? How would you expand that? Ln 5 divided by 8. What would that look like? When you see dividing inside the logarithm, what are you going to do? So it's ln 5 subtract ln 8. Because when you see dividing, if you want to expand the logarithm, you do what? Subtract. How about this one? Let's write it calculus-like. What would it look like if you did it with calculus? X squared plus 1 to the what? What property would we use here? Where can I put the 1/3? Is there a property for adding inside a logarithm? No. For multiplying, yes. For adding, no. That's it. How about if you have a logarithm that's already expanded? Put it back together like Humpty Dumpty, right? The key is, do both logarithms have the same base? Because if they had different bases, you can't combine them as one logarithm. What's the base? E? What will that look like as one logarithm? I know I'm scratching a part of your brain, right? That the file folder is just barely opening up. Is that right? The number in front of the logarithm represents what? The exponent. On what base? X to the -3. Adding means we're going to multiply. And then again, the 5 in front represents the... What's another way we could write this? It's okay to rewrite things algebraically. You never know when you need that skill, right? To give you an out when you don't know what to do. The next one. How do I write this as one logarithm? Do they all have the same base? Okay, let's write it as one logarithm. What's it going to look like? What does this mean? So the exponent x to the 1/2 means the same as root x, right? Adding means we're going to multiply. Subtracting means we're going to divide. And what's the exponent on 3? And you did it. All right, turn the page. All right. Do you know how to solve that equation? Not using your calculator? You're going to use a logarithm, right? Now, in order to do that, you first have to isolate the exponential part. So what part is the exponential part? E to the... So to isolate it, we're first going to do what? In order to solve for x, we need to write it as a logarithm, because a logarithm is the inverse of an exponential. How do I write that as a logarithm? Don't be complicated. What's in the exponent? What's in the exponent? What's the base of the logarithm? E, so it's what? Ln, and then what goes inside? 6, right? There it is. Now what would you do to get x by itself? You would add 5, and then you would divide by 2. So it would be ln y minus 6. We're going to add 5, and then divide everything by 2. The algebra is the real sticky point in calculus, right? The calculus concepts are okay. It's the algebra that gets in the way, right? B. How would you solve for x there? How would you get x by itself and everything else on the other side? Look at it. Well, do you notice that we could write that as one logarithm? We got this. When you see subtracting, what do? So I'm going to write the left side as one logarithm. So subtracting means we're dividing. So what are we dividing? X over is equal to, what would you do next? Write it as an exponent, because what undoes a logarithm? Exponent, right? Like adding and subtracting, multiplying and dividing. How do I write this as an exponent? Let's start with the answer. What's the answer part? What's the base? And what's the exponent? Keep going. What is 2? And I'm going to continue right here. What's 2 cubed?
8.
Okay, keep going. X is not by itself yet. What would you do to... By what? So if I multiply both sides by x minus 8, the left side divides out, but on the right side, can you distribute in one step? So in other words, it's x minus 8 times 8. Now what? Subtract 8x, what would you get? And then what would you do last? Divide by negative 7, and what does x equal by itself? Isn't that FUD algebra? I know. It's tough, right? All right, let's continue. Change a base formula. You know what? Take out your calculator. And the fun part is, if you're allowed to use your calculator, you don't need to change the base, because you have the fancy-dancy one that you can put any base in. I'm listening. We got it? Talk to me, Candy. Can you take out your calculator, turn it on? I'm still listening. By subtracting 8x to bring the x's together. 1 subtract 8. If that's the biggest issue, right, we're in good shape. Do you have a calculator with you? Hey, do you know that your calculator does logarithms so sweetly? Do you know that most science, like the calculator you used last year, the TI-89, that it was complicated to use a log? It wasn't even on the interface. You had to go to the catalog and all that. Look at this one. Do you know where log is on here? It's hard to... Do you know where... There it is, right? Do you see where log is? What do you think you're going to press to get there? Good. Let's do that. So control and that. And what do you notice that pops up right away? That means you can put in any base. Isn't that beautiful? So just type in when it says, what's log 112 base 7? All you do is put that in. Now, if you press equals, it will just give you, spit it back out at you, right? So go control and enter. Can you see how you can evaluate any logarithm quickly with this calculator? Other calculators, you'd have to change the base and use a special formula, but not this calculator. So the formula is up here, but with our calculator you don't need it. It says find an exact value for x if that's what it equals. If you want to find the exact value for x without your calculator, you'd have to use a logarithm, right? What would it look like? The exponent is, the logarithm would have what base? And inside the logarithm? And then what would you do to get x by itself? Subtract 2. That's it. That is the exact answer for x without rounding. If I wanted to know the exact value of that answer, could you do it? Now use your calculator. What would the exact value be? Press the log button. Base is 3. Inside is 6. Move that cursor over. And then you subtract 2. Go Control Enter. Did you get negative 0.369? All good, right? Why do another lesson when this one's pretty by itself, right? You need practice on that. That's why I do this with you to see, oh, this is easy. I remember all this, or like, oh, I need to review something. Anyways, Mr. G Math, over and out.